Thank you everyone for joining us today. Gurobi was founded in 2008, and to date we have over 1,600 customers worldwide. As a solver company, of course we take performance very seriously. We are consistently the public benchmark winner. In just our latest release, version 7.5, which was a minor release, not a major release, we saw an average speed up in excess of 40%. We offer outstanding support. Our technical staff is made up of all PhD level optimization experts, each with over 10 plus years of commercial experience. These are the people you reach immediately, not 5 days later. When you have a technical question, you will be talking to one of them. And our admin and sales staffs are extremely responsive as well. Whether you need a license transfer or a quote, we are here to help. Our pricing is published on the website, and we are always interested to hear about your needs, and we'll work together to come up with a proposal that works for both of us. Our goal is to ensure that you're successful using our optimization solver. I mentioned our performance relative to speed, but as you can see by this graph, with each new release, our robustness has improved as well. The number of unsolved models is down to 64 with a time limit of 10,000 seconds. In addition, we continuously work on adding new features and ease of use tools. In our latest release, version 7.5, we added several Python modeling enhancements, as well as simplified our multi-objective interface. I think the most important thing to note is that we have one product. Unlike our competitors, we are 100% focused on making sure we have the best solver on the market.
Thank you, Tracy. As we start today, the topic of today's webinar is Beyond an Optimal Answer: How Optimization Adds Unexpected Value to an Organization. We wanted to give you a little context of where we're coming from to provide you some sense of where the insights we're going to be talking about today have their genesis. My name is Russell Halper. I'm with a company named End-to-End Analytics. We have a partnership with Gurobi. We are a consulting firm primarily based in Palo Alto, California, and we focus on helping our clients in 3 different ways. We work on management consulting, analytics consulting, and technology consulting. But as you can see here, analytics consulting is at the center of what we do. We have resources located across the US, as well as internationally in South America and Asia. And in terms of the motivation for the talk today, a lot of it's coming from our work across a number of key verticals: automotive, high tech, retail, consumer, financial services, and about 30% of our work falls into a quote unquote all other bucket. Many of the examples that we're going to talk about today have their roots in our supply chain and manufacturing work, which obviously is a big application for mixed integer programming. That said, there are definitely other application areas for mixed integer programming beyond supply chain and manufacturing. And while most of the examples that we're going to talk about today come from that space, we believe the insights that we're going to discuss are broadly applicable to most people who are using mixed integer programming to help improve their organization. Similarly, as a company, we work both across prescriptive, predictive, and prescriptive analytics. And we have insights as appropriate that we've packaged in here and brought in to talk about how to get the most value out of Gurobi as you look at implementing it for challenges in your organization. So enough with the introduction. Let's start diving into the talk. Today's talk we've broken up into 3 different pieces. As we mentioned, the topic is how optimization adds unexpected value to an organization. So the first thing we want to do is talk about baselining how optimization is generally perceived in an organization. What are the common ways that both practitioners and executives may view the value that optimization brings when they look at implementing it as a potential solution? Once we discuss that, we'll talk a little bit more about what other types of value does it bring to your organization. And then finally, we'll leave you with some tips about how you might be able to achieve some of this value in practice. As a motivating example, I wanted to talk about one of my favorite articles on prescriptive analytics. And before talking about it, I will put out a little disclaimer that we neither have worked on any of these systems in this article, nor with any of the companies in the article. So we are talking more about the contents of the article than its accuracy. However, I think there's some very important insights and lessons that can be learned from this article. And what it talks about is scheduling of retail workers in various chains. And if you think about, you're a manager of a store, potentially a big store with many different departments, and you have to put together a labor schedule for a number of part-time retail workers who may have different expertise that, you may need somebody who can be a cashier, you may have somebody who has to work in a stock room, you may have a department that requires somebody with specialized knowledge about that department. That scheduling problem can be very complex. And certainly there is a lot of cost associated with that schedule. There can be overtime costs, there can be benefits costs, and there can be certainly implicit costs if you're not able to adequately staff part of the store. So traditionally, when this has been done with a spreadsheet or, by manually, it was a very complex scheduling process to do, and it would somebody take a long time to put this together. And naturally, this is a great area to look at bringing optimization or other types of prescriptive analytics into. And this article talks about implementing different types of workforce scheduling systems and what types of implications those have had. And it talks about how many of those systems are there to really control costs, right? How do I come up with a schedule that satisfies my labor requirements and minimizes the labor cost? But an unintended side effect of a lot of these types of systems were what happens with the quality of lives of the employees in the store. So, retail employees sometimes may have a second job or may also be a student. So they have other constraints around their job. And when schedules started coming out of these systems where they had inconsistent number of hours from week to week or inconsistent timing for when their shifts were during the week, it was causing lots of problems where many of these retail workers started looking and saying, hey, how this is problematic for me. Am I going to be able to stay at this job? And it doesn't mention in this article, a common metric for how much it costs to train a worker is 1 year of salary. So if you start having situations where you have high turnover or employees not showing up or new employees coming in which aren't as knowledgeable and aren't able to provide the same amount of customer service, there are either explicit or implicit costs associated with that weren't considered in the model. For those of us who are practitioners of optimization, understand, many of these could be built into an optimization model. And in some systems, it mentions in this article, they were built into the system. But, I think the very important lesson here is as you think about building out a model, what's all the value we're providing? And how do we make sure we're providing the maximum value, right? I would contend there was probably likely a way to avoid some of these hardships while still giving a very good schedule to the store. And I think appropriate analytics strives to provide value in many ways beyond just simply, myopically optimizing an objective function. So throughout this talk, when we talk about value, we're going to talk about it in a number of different ways. So obviously, one of the benefits of implementing Gurobi for problems or mixed engineering for problems is that we will come up with a very good solution, either low cost, high revenue, right, maximize profit, etc. But there's other types of value that Gurobi can provide. So what does it provide to the business end user? What type of value does it provide to a business process? What type of value does Mixed Engineering Program provide to an analytics team? And what type of value does it provide to IT? So to begin, as we start talking about analytics, right, and how it's perceived in an organization here in this first section, I think it's important to highlight something that sometimes gets missed, especially within some optimization teams or some analytics teams, that analytics is primarily there to help, in this case, I'm pulling from Wikipedia, describe, predict, and improve business performance. And I think that is very key, right? What's the most important thing for an organization when we're looking at how do we do this is how do we move the needle for the organization? How do we make sure that the investment they're putting into their analytics is paying off? And part of the problem is for, some organizations or some people, they have trouble even identifying where to begin with analytics. So if we think about where optimization comes into play, certainly that is a subset of where to begin with analytics. Normally we recommend looking at 4 different things. Do you have a business problem? Do you have data? Do you have a vehicle for communicating results? And do you have some process in place for taking those results and turning them into actionable, pragmatic business advice where you can measure their impact. And if you can do all those things, then it's a good candidate for applying analytics in an organization. Now, moving into optimization, there's a long list of canonical use cases that people often look at for optimization problems that many of us are likely aware of, like looking at network design, looking at scheduling, looking at auctions. However, oftentimes it's helpful to put out a framework where it's not so much looking at individual use cases, but how do you identify what types of problems in an organization derive value from optimization. And this is one slide we've recycled from our previous webinar with Gurobi. But the two things we like to mention when you're thinking about optimization is, first, look at the degree of control on the business problem that you're thinking about. For prescriptive analytics, generally you want something that your business has a high degree of control. And what we mean by that is when your business makes a decision, when they say pull a lever, that impact to the organization can be reasonably understood, right? So for example, if I'm scheduling a factory and I make a decision, we can understand reasonably what the effect of that schedule is going to be at the factory, right? If we are trying to understand what the portfolio of trade promotions might look like, and we're trying to pick a particular trade promotion or a set of trade promotions to run for the year within a set of guardrails, we then want to understand, if I pick this promotion in this time, what do we predict the uplift is going to be? The second axis we need to think about is how quantifiable is the problem, right? We need to make sure that the problem is reasonably quantifiable. Now, when we say reasonably quantifiable, obviously any problem where you might be able to look at it and say, here's the cost of this type of solution, or here's the revenue we expect to generate from this type of solution, likely will fall into that category. However, there's also a category of problems where there might not always be an explicit cost or revenue associated with decisions, but it's possible to generate some reasonable proxy data that represents the relative value of different decisions being made. And that's the bar that I think we need to get over. We recommend you have to get over to have a quote unquote reasonably quantifiable problem to consider for optimization. So as we start thinking about value, let's think about some common optimization applications. So here we have a number of different common applications, from minimizing distribution costs, minimizing infrastructure investment costs, production costs, procurement. I like to use the term right-sizing inventory, maximizing trade promotion revenue, and maximizing auction revenue. But typically you could break these into two different categories, with the inventory problem perhaps falling somewhere on the border. But minimizing cost or maximizing revenue, which both fall under the umbrella of profit maximization. However, this view of how we look at these problems is a little bit myopic, right? And I think it doesn't really capture all the value that bringing in optimization into these problems really provides. So for example, anybody who's worked on a distribution problem, network design problem, knows that seldomly is the true least cost solution ever implemented, right? In most times when you're looking at a network design, a number of different scenarios are run, and then a solution is picked, which is a very low cost solution for a scenario, but also has a number of qualitative aspects that are beneficial to the business. Similarly, there might be difficult to quantify constraints. So for example, if they're union contracts, there's part of that which is quantifiable, right? There may be different labor costs associated with using a union rather than using non-union employees. However, if you want to move out of a union facility, many businesses are sensitive to what type of PR image that would be. So there's a strategic consideration to be considered, which sometimes is not always very quantifiable. If you look at procurement costs, organizations oftentimes want to source from multiple vendors. So they would want to look at make sure that any optimization may have certain types of constraints built in to ensure whatever strategic decisions they want to make around procurement remain intact. And if you look at something like maximizing trade promotion revenue, right, trying to come up with a portfolio of promotions for your items that are going to satisfy a number of constraints, there are certainly considerations in there around, well, you might have many different objectives in a trade promotion revenue campaign. So for example, Trade marketing strategies might include maximizing ROI, volume, revenue, share, and there's other strategies that might be in place as manufacturers fight for shelf space at retailers. So we can see that as we start peeling back the layers of the onion from these problems, thinking about them as either least cost or maximal revenue problem doesn't always necessarily describe all the value we get for optimization, right? For each one of these things, we can look at an optimization model and articulate different ways that it's going to provide value to answer each one of these questions in these boxes on the right. So as we go into the rest of the talk, well, our goal now is to answer what's all the different ways, or at least a number of different ways, that optimization can provide value to organization beyond simply finding a least cost or maximal revenue answer. So diving into section 2, we want to start off with a conceptual exercise. And in this case, factory scheduling. Similar to labor scheduling, as we talked about earlier, factory scheduling, another very complex problem. You pick up many of the same constraints you might have in terms of having different resources you need to schedule, potentially with different skill sets. But then there's also just the difficulties of scheduling the factory, right? You might have a very complex production process with a number of complicated constraints that span different parts of the factory. In addition to that, demand might be able to change rapidly. There's oftentimes many decisions that need to be made. And there may be, in certain types of environments, intermediate width or storage constraints that also need to be built in addition to scheduling the actual equipment. So this, again, another example of a very complex problem where optimization has the potential to provide a lot of value. And when we have worked in this space, we often see that these problems are done manually by scheduling teams, which spend a lot of time to put together what they feel is a good schedule. We've seen environments where to generate the schedule for the next 5 days takes 3 days of their time. So there's sort of one question here of how optimal is that schedule, which, general assumption is that mixed integer programming can generally outperform human for most of that. But let's put that aside for the moment and think about another issue. It takes them, in that example we mentioned, 3 days to create a schedule and 1 day during the week to revise it. Well, anybody who's worked in a manufacturing environment knows that there's oftentimes issues that come up with either maintenance or equipment breakdown or attainment, or in some cases, staff not showing up as anticipated. And as soon as you start implementing that plan and start executing upon it, there's this tendency for the factory to intentionally otherwise start deviating from it for those reasons. My favorite quote around this is actually from Mike Tyson. Everyone has a good plan until they get punched in the mouth. It's also a good military quote around this. No plan survives first contact. But in reality, like many supply chain processes, a plan is put in place. Once that plan starts being executed upon, there's natural deviation from it. And at a certain point, there's a need to come back and replan it. And in the factory scheduling context, especially when their KPIs might be measured with weekly attainment, that type of the need to come back and revisit this they often need to come back and revisit this multiple times during the week. And so I think about the value optimization provides is in this context, it can allow them to come back and much more quickly respond, right? In the example that we mentioned before, if it takes them a full day to update the schedule in a 5-day work week, that means the inputs they collected by the time that new schedule is implemented are already a day old. So they're already behind when they're trying to start putting that schedule in place. So being able to accelerate that process can help drastically provide value to the organization in both giving a better quality solution and a more relevant solution because we're able to generate it quicker with a smaller delay between the inputs and the outputs. And this leads us to our first area where we think optimization provides value beyond just the answer, which is in accelerating workflow for an organization. So a typical planning cycle might look something like this. A set of inputs is collected. Those inputs are then used to create a plan. That plan then needs to be communicated out to whatever part of the organization is executing it. and then they need to execute upon it. And inputs are then collected from that execution and perhaps other places in the organization, and the cycle repeats itself. This may be a weekly cycle, a daily cycle, a monthly cycle, depending on the type of problem you're looking at. But typically, there is some type of iterative process where in operational prescriptive analytics, some decision is repeatedly being made. So if we think about implementing optimization, how does it help each stage of the cycle? So first of all, input collection. Typically, bringing optimization into play means that we've automated collecting a number of the inputs. That may differ in certain environments. We've certainly seen environments, but before optimization was put into place, those inputs were collected manually, and that itself took a lot of time. And you could also argue how value added is that time for the planner to actually spend. The second one, think about the plan creation. So obviously, the goal here would be to create a higher quality plan and be able to create it more quickly with mixed integer programming. Communicating the plan out to the floor. Right now we have a structure in place. We have a systematic set of outputs that are coming out, and we can focus more time and resources on developing the appropriate communication strategies, right? What type of reporting and descriptive analytics is needed, not simply to create the plan and tell people what the plan is, but to also get their buy-in on the plan, right? So when it comes time to actual execution, they will look at it and have faith that what's coming out of this planning process is something that they can go and put in place. Because obviously, if they're not willing to execute on it, we're not going to be able to achieve the value that we like to from the problem. And then, of course, once we get through that stage, there's hopefully the benefits we find in execution by having a more robust plan.
Optimizing for multiple objectives. Many optimization problems can have multiple goals, and now Gurobi has built-in features that help you solve models with multiple objectives. And there's two ways to handle this, hierarchical and weighted. So for example, if we think about the article Russell mentioned earlier, an employee scheduling application may have two competing goals. One, to minimize cost, and two, to improve the quality of life of its employees. So when solving hierarchical objectives, each objective is solved separately in order of their ranking. When solving for a lower ranked goal, Gurobi will constrain the degradation of higher ranked objectives and then solve. These built-in features can accelerate the model building process.
Being able to go and use Gurobi for multi-objective optimization is great because it's got some of those built-in features. Another area where we could look at how value is provided is in scenario analysis. Typically, when many people think about scenario analysis, it's around how do we look at different sets of data or different sets of constraints and put them in the model and understand what comes out of the model. And that certainly is part of that. But just as important is understanding not just what the optimal solution might be, but what's the second most optimal solution? What's the third? What's the fourth? And what might be the gap between them to understand how robust or optimal a certain solution might be compared to the next one down the list. One of the ways to think about how this provides value, which you can see here on the right, shows a commute from San Francisco to Palo Alto. And as you can see, when you go to Google Maps and you put this in, it will come back with, right away, several different options around what you can look at. So on the right here in blue, it shows 101, which is a shorter route, but oftentimes has more traffic. And it's also through relatively urban or suburban areas. And on the left is 280, which is a longer route, but it's through nice rolling hillsides and typically is less traffic. And you can see here in this case, I have two different solutions, relatively comparable objective functions, right? One says it's going to take 48 minutes. The other says it's going to take 50 minutes. And the question is then going to be, which one of those two solutions should be implemented in practice? Well, a myopic view might say, I want to take the 48-minute one. However, that route has more traffic, so it's likely a less robust solution, right? Traffic could build up more easily, an accident could more likely happen. And that means if I think about sensitivity analysis, that has less desirable properties. Not only that, 280 is a much nicer drive. It's through rolling hillsides rather than through suburban areas. So there's a reasonable argument here about why a driver might want to take 280 here as opposed to 101. Similarly, with optimization, when you're thinking about scenario analysis, it's the same concept that applies. And one of the great tools that Gurobi has is solution pools to be able to go and take what are the K most optimal solutions for a problem with the same set of data, the same set of constraints, and then have them to be able to compare. And if you could build the right types of descriptive analytics, the right types of reporting to be able to easily compare those scenarios, that could provide a lot of value in terms of, making sure that whatever solution the business chooses to implement has both good quantitative and qualitative properties that they're going to feel comfortable with. A couple tips for effective scenario analysis. First thing we always recommend, make sure you have a robust data structure where you can easily create and maintain scenarios. Very similarly, make sure that you're always storing all the non-zero variables from your optimization problem for each scenario. Generally, time is much more expensive than storage. So assuming you have the storage space, we find it almost always beneficial to be able to store that data, at least for the duration of the project. Secondly, make sure you have a robust set of either reporting or descriptive analytics for compared results. Visualizations we find are key, where you can quickly see the impacts of different scenarios or different solutions for key parts of the problem. As you can see in the previous slide, when we have the map up, that gives us all the information we need in one place. We recommend having some type of process to make key business decisions about scenarios before running those scenarios. So who are the stakeholders that need to be in that process? What are the different KPIs you need to have in place? And how do you make sure that you have agreed on how you're going to start evaluating those scenarios before they're put in front of somebody to make sure you get to the right solution? And then, of course, which we talked about, for any functionality Gurobi might have that helps you accelerate how much time it takes to create your solutions, try to take advantage of that. So we've talked about automating workflow, and we've talked about scenario analysis. And in a lot of organizations we've worked with, there's oftentimes a problem of, I still want to take the results from the model and put my hands on it, right? I want to still take out what the model's saying. I want to play with it. I want to put my own intuition on top of it, because there might be some insights or constraints that aren't always represented in the data, or qualitative considerations I wanted to put into place as we are looking at, for example, how I might want to prioritize one customer's order over another. And the business wants to take the results of the model and play with it. And the question becomes, how are we providing value in those situations? Well, typically, you can make an argument, or just sort of this Pareto principle, that 20% of the decisions make 80% of the value. So when looking in those types of situations, the question becomes, what about the other 80% of the decisions? We can automate that, right? That's going to reduce the amount of time the planner is going to take, and they could really focus their time then on the value-added activities. Now, conceivably, they're already focusing time on those activities, which means we've freed up additional time from those resources, right? So we're essentially acting as a workforce multiplier. And what that can mean is those resources then have more time available to go look at work on things like, how do we communicate the plan to whatever part of the organization is executing upon it? How do I monitor execution to understand, what are their pain points, so we can iteratively bring those back into the planning process? And how do we go and make sure that we're doing all the appropriate reporting and other types of sort of day-to-day tasks in the organization? So what this really means is you could take a planner and hopefully, in certain situations, reduce the amount of time that they're spending planning, and allow them to sort of play the role of a planner/analyst. We refer to it as a exception-based decision-making process, where now, instead of spending all their time on this busy work, they're now spending their time on the incremental exceptions to the plan that are driving incremental value for the organization. One of the other great things, if you're thinking about different types of prescriptive analytics, is that Mixed Signature Program provides a lot of flexibility. If you think about building a heuristic for a problem or machine learning for a problem versus tackling it with Mixed Signature Programming, one of the very nice things about Mixed Signature Programming is, as either my constraints change or my data changes, you can very easily update that Mixed Signature program, right? If I need to add a new constraint or I need to change my objective function, that can be done pretty quickly, and you're assured by the nature of mixed integer programming that, if you were able to solve the problem, you're getting a optimal solution. There are certainly some situations when putting in a heuristic, depending on the types of constraints that might change in the problem, that a heuristic might need to be entirely redone with a different approach, depending on how drastically that problem changes. And even if that heuristic does need to be redone, there does need to be a fair amount of testing to make sure that it's still performing properly. If I look at mixed integer programming versus machine learning, machine learning is a great tool. It has a lot of phenomenal applications that we work with. But one of the nice things in certain situations is that you can be more proactive with mixed integer programming to address changes in the business. So there are certain types of changes that might happen with certain types of machine learning models where we're going to need to wait before the machine learning model has enough data to be retrained to address those changes in an organization. With mixed integer programming, because we're not training the model on data, we're finding a optimal solution to what we think is going to happen in the future. It doesn't have that same lag necessarily, so it's able to keep up with the changes in the business potentially more easily. So what does this mean for both the analytics team and the business? For the analytics team, it means I can guarantee I'm getting a high-level quality solution out of the model we're providing to the organization. I mentioned you can implement it being able to, without seeing past considerations, but also, if I'm the manager of an analytics team, one of the things that I want to think about is how much resource time do I need to put towards maintaining whatever solution I put in place? And if done right, you can come up with oftentimes a efficient way to maintain some of the problems for mixed integer programming. Potentially less code to deploy too, which is that nice IT friendly, right? If you have a heuristic which is coded, does that mean you need to redeploy a package or redeploy a solution? Versus if I'm updating a constraint in a mixed integer programming model, perhaps I just need to update a script somewhere. Now, again, that depends a lot on how you set up each one of those two types of scenarios, and there's different ways to set them up, but certainly in some situations, that may be an advantage. For the business, if you think about how businesses want to be flexible, when we do technology consulting and help organizations select the right software, one of the things that they are almost always concerned about is what happens if my business changes, how robust is this going to be, what type of support contract do I need to put into, and how much cost is that going to be for me. So one of the nice things about this flexibility is it does help the business with those problems. And hopefully what that means is as your business changes, if you implement a model now and find out you need to make a change in a year or two, you can do that more quickly and get back to achieving the ROI from that solution that you'd like to. The other thing to think about too is, if I go back to my hat as an analytics manager, how do I make sure that I'm providing a service to the business and having a good relationship with, and having a flexible solution is part of that, right? Being able to make sure that we're able to quickly respond to the business and provide a high level of service to the organization generally means that they're willing to hopefully be more willing to accept the results of the model and implement the solution, but also hopefully more willing to work with us in the future to go and build out additional types of solutions in an organization. Now, the other thing to think about is what just does the process of building a mixed integer programming model do for a company, right? Think about just your starting point is, you have a manual planning process. Perhaps there's some decision support tools that provide the data needed to make decisions, but there's no prescriptive part of those tools that are making decisions for you. And we're now moving towards a more prescriptive process by looking at implementing mixed integer programming. Well, challenge number one here, we might see some organizations where decisions are being made based on rules of thumb rather than some type of rigorous analysis. Typically when putting in place mixed integer programming, actually it means imposing some of that rigor on the organization, right? We're going to standardize a set of data we're going to collect. We're going to standardize a set of decisions that are going to be made. We're going to go and understand what are those decisions that can be made. One of the things that we often hear when thinking about this as well, I don't have the data quality to really start doing this. And one of the things we recommend is saying, hey, best way to learn how to do something with your data is to start using the data, right? You're not going to clean it up until you have any real impetus to do that. So That's another part of challenge number one here. Challenge number two, decisions being made in isolation or in silos. Naturally, many mixed integer programming applications look at how do I balance competing KPIs or objective functions or goals across neighboring parts of an organization. So for example, in manufacturing, to go back to our manufacturing discussion, a factory may want to run long production runs because that reduces their change over time. However, supply chain may want them to run many short production runs because that reduces their inventory. So naturally, we have this conflicting set of KPIs for adjacent processes, and if we can consider both of those aspects when looking at, say, a long-term master production schedule, that can help the organization to understand what's the true unbiased approach the organization should take to reducing their cost. Similarly, in a network design, right, you might look at balancing distribution costs versus DC space versus manufacturing investment. Same type of concept, conflicting costs, right? And how do we find the least cost solution for an organization? Challenge number three, organizations often repeat mistakes. No closed loop process. Where we talked earlier about, hey, part of bringing optimization in place is not just building the model, but creating the process and structure around it that allows the model to be successful. So how do we make sure that as practitioners of analytics also put on our quote unquote consulting hat for the organization to help them understand how do they streamline or work with them to help streamline this process and make this cycle more iterative. So now we'll talk a little bit about what are some things you can do to realize this value in practice.
So why Gurobi is the best solver to unlock this value? We are the proven fastest solver on the market. This can be verified by checking the latest public benchmarks. In addition, we are always happy to extend an evaluation license so you can do your own benchmarking, or we are available to help by benchmarking your models on our systems. We can also help you tune your models any way that you if you're looking for optimality, feasibility, we're happy to take a look at the models and suggest specific parameters, etc. We support several different deployment environments. We have a proven seamless solution for the cloud. Our APIs are designed for ease of use and maintainability. In comparison to our competitors, the feedback is our APIs are significantly better. We offer advanced modeling features, and we regularly check with our customers to see what features you would like to see. How can we make the product better and make your jobs easier? So please don't hesitate if you have an idea, if you feel like there's something that you would like to see in the product, don't hesitate to send us an email, give us a call. We're happy to entertain any ideas.
As we wrap up today, what we wanted to do is a quick summary and give you a 5-point framework for identifying not just optimization opportunities, but impactful optimization opportunities in your organization. So first, is there a business decision process, something that has a high degree of control, that is reasonably quantifiable, where there's also a solid understanding of the different levers that can be pulled, right, the different decisions that can be made, and the impact of those decisions? Does data exist or can it be manufactured? As we mentioned, oftentimes organizations might let data quality stand in the way of doing analytics, but the best way to clean up your data is start doing something with it. Number three, can the set of decisions, a solution be quantified? Right? Example, as we mentioned before, we want to make sure we have a reasonably quantifiable solution. Then we need to make sure we define the value to the business process. And we mentioned a number of different ways today that you can do that, from automating the workflow to time saving, scenario analysis, right? Sometimes you just need something for survival. You need some type of decision that can be considered all the facts, and it might not be able to be done without some type of analytics, and flexibility. And lastly, and this can't be understated enough, having a methodology in place for how you engage the business and how you ensure whatever type of optimization model you're looking at ends up being successful is just as important as the quality of the model. We need to make sure that we're getting buy-in, we're getting support, and that we're satisfying the concerns of the business user. So thank you all for joining us today.